Okay, in example number 2, we have a separable equation with an implicit solution. So we're going to solve the differential equation dy over dx, which is equal to 6x squared divided by 2y plus the cosine of y. So the first thing we want to do is we're going to multiply both sides so we have all the terms on y on one side and all the terms with the x on the other side. So we're going to multiply the left side on both sides by 2y plus the cosine of y, so we're going to end up with 2y plus the cosine of y dy, and then it's going to equal 6x squared dx. And then we're going to integrate both sides, so we're going to integrate the left side and integrate the right side. So when we take the antiderivative of 2y, we're going to get y squared. When we take the antiderivative of cosine y, we're going to get plus sine y, which is equal to the antiderivative of 6x squared is 2x cubed, and then plus c, where c is a constant. Now, equation 3 gives the general solution implicitly, so in this case, it's impossible to solve the equation to express y explicitly as a function of x. If you take a look to the right, it says some computer algebra systems can plot curves defined by implicit equations. Figure 2 shows the graphs of several members of the family of the solutions of the differential equation in example 2. As we look at the curves from left to right, the values of c are 3, 2, 1, 0, -1, -2, and -3. Okay, so now I want to add to this question, because what we want to do is, let's find the solution that satisfies the initial condition where we have y of 1, which is equal to pi. So what we're going to do is we're going to use that solution that we got in that first part. We have y squared plus the sine of y, which is equal to 2x cubed plus c. And what we want to do is we want to be able to find c using this initial condition where we have x is 1 and y is pi. So we're going to plug that into the second part. And we get pi squared plus sine pi, which is equal to 2 times 1 cubed plus c. So we have pi squared. We know that the sine of pi is 0. And then we're going to subtract 2 to this side. And so we end up getting a constant c, which is equal to pi squared minus 2. So the particular implicit solution is y squared plus sine y, which we got in the first part, which is equal to 2x cubed plus c, but we found c then to be pi squared minus 2.